Hi everyone, this is Karthika, Faculty of Physics working in SNS College of Engineering. Today I am going to give some explanation about the semiconductor physics. Differences between elemental and compound semiconductor. So if we go for elemental semiconductors means they are made from a single element and that will be a compound for a compound semiconductor. So these materials can be taken from the fourth group and sixth group for elemental semiconductor. But if we go with compound means they are taken from the combination. So they can be taken from third and fifth group or second and sixth group. And it is also that elemental semiconductor can also called as a indirect band gap semiconductor, that is electron hole recombination takes place through the traps. But if we go with compound semiconductor, these are called as a direct band gap semiconductor. Here electron hole recombination takes place directly, and then heat is produced in the recombination process, and in compound semiconductor photons are emitted. So elemental semiconductor produces heat during combination and compound semiconductor produces photon during the recombination. And lifetime charge carriers is more in elemental semiconductor, but in compound semiconductor the lifetime of charge carrier is less. And current amplification is more in elemental semiconductor and current amplification is less in compound semiconductor. And these are used for making diodes and transistors. So elemental is used for making diodes and transistors, and compound semiconductors are used for LEDs and laser diodes. And we have already seen the example, that is silicon and germanium for elemental semiconductor, and then gallium arsenide and phosphide, gallium phosphide, cadmium selenide and manganese oxide. These are the example for compound semiconductor. Next, the types of semiconductor. This is nothing but the based on that is impurity added. So there are two types. So one is intrinsic semiconductor, another one is a extrinsic semiconductor. And if we go with intrinsic, is nothing but the pure form of semiconductor. There is no any other elements added, that is called impurities. So pure form of semiconductor is called the intrinsic semiconductor. So example is silicon and germanium. And if we go with extrinsic means that is adding or doping impurities with the pure form of semiconductor, we'll have a extrinsic semiconductor. So in that again we have a two classification, that is N-type semiconductor and P-type semiconductor. So N-type, how we can get the N-type from pure form of semiconductor means we have to add pentavalent impurities to the pure form of semiconductor. So penta means 5. So there should be the 5 valence electrons in the outermost orbit. So that will donate 1 electron to make the covalent bonds here. So this type of this N-type or pentavalent impurity is called as a donor impurity. So example for pentavalent impurity is nothing but phosphorus, arsenic and antimony. So these are some examples. And if we go with P-type means that is nothing but adding trivalent impurity. Tri means 3. So we need 4 valence electrons in the outermost orbit to make the covalent bond with the semiconducting material, but here we have the 3 electrons only. So this is called the acceptor. So it will get 1 electron from the another atoms. So it will accept the electron. So it is called as a acceptors. So example is gallium, indium, aluminium and then boron. These are the some examples for trivalent impurity. And how we can define the intrinsic semiconductor means it is also called an undoped semiconductor, or I indicates the intrinsic type semiconductor. It is a pure form of the semiconductor without any significant dopant species present. So number of charge carriers, it is here determined by the properties of the material what we have taken, so and the amount of impurities. So next one is the extrinsic semiconductor, and it is nothing but doped by specific impurity, so which is able to deeply modify its electrical property, so making it suitable for electronic applications, that is diode, transistors and auto electronic appliances. So these can be used for the other purposes, that can be light emitter or in the detectors. So next one is the difference between the intrinsic and extrinsic. So from their properties, we can say the differences. That is, first we can say intrinsic is a pure form and extrinsic is nothing but a impure form. And here the charge carriers are produced only due to thermal agitation. So due to the thermal energy, the charge carriers are produced. So but in extrinsic semiconductor, the charge carriers are produced due to impurities and may also produced due to thermal agitation. Then in intrinsic semiconductor, they have low electrical conductivity, but they have the high electrical conductivity in extrinsic semiconductor. And in intrinsic semiconductor, they have low operating temperature, but extrinsic semiconductors are high operating temperature. They have high operating temperature. At 0 Kelvin, the Fermi level in intrinsic semiconductor exactly lies between the valence band and conduction, but it varies, depends upon the n-type semiconductor and p-type semiconductor. So in n-type semiconductor, Fermi level is exactly closer to conduction band, but in p-type, that is exactly lies near the valence band. And already we know the example for pure form, that is silicon and germanium, and extrinsic semiconductor, that silicon and germanium doped with some impurity atom for the type we required. So the example for impurities already we have seen, that aluminium indium phosphide, or that might be a gallium, indium, phosphorus, so that and all. Thank you.